Hi, everybody. I'm really happy to share with you this super preliminary work, as Hugo said at the start of it so far. Let me introduce myself. I'm Martina Finocchiaro, and I'm a PhD student from Marie Curie European project from two universities. One is Universitat Politecnica de Catalunya in Barcelona, and the other one is Scuola Superiore Sant'Anna in Pisa. This work is about the use of software simulation to develop and test human-machine interfaces for intraluminal robotic surgeries. So during these 10 minutes, I will cover these topics. So first, I will introduce a bit about the project I'm working at, which is the Atlas project. And then I will give you some background knowledge on robotic-assisted intraluminal surgery, and in specifically colonoscopy, which is the procedure that I'm targeting, and the role of human-machine interface. I will later explain the problem, the challenge, actually, I would like to address, and how to do it with the simulation, and we'll show you a short demo about what I achieved until now. So Atlas, it's this European Marie Curie project aiming at the training of 15 PhD students like me around 7 universities. We all work on the same topic, which is autonomous intraluminal surgery, but each of us is working on a different subtopic. And we also are very lucky because we can collaborate with many external partners. Intraluminal procedures are a specific subset of minimal invasive surgeries in which a long flexible shaft, which is called endoscope, is inserted through a body cavity through natural orifices, such as, I don't know, the mouth or the anal sphincter. And the endoscope is navigated inside the lumen without violating the boundaries. So this procedure has little invasiveness for the patients, but on the other side, it becomes more complex for the operator due to the low workspace available. Here you can see some example of a robot platform used for the intraluminal procedure. Now, the specific procedure that I'm targeting is colonoscopy, which is widely practiced around the world, and it actually works with the long endoscope, which is navigated inside the colon in order to detect adenomas, which are potentially tumoral masses. And there is a camera at the tooltip, which allows the user the endoscopist to visualize the internal intestine. Actually, although this procedure is the gold standard screening method for preventing colorectal cancer, there are still many concerns. For example, many studies prove that up to the 22% of adenomas are not detected during the procedure. The passive nature of the shaft, together with the low controllability and the limited workspace, makes the procedure hard to learn and to master. And also the non-ergonomicity of the handler actually make it induce many musculoskeletal injuries to the endoscopist. For this reason, many groups develop different robotic platforms, such as snake-like robots, or multi-cerebral robots, or endoscopic capsule. And these actually add extra degrees of freedom and extra sensory information to process. And so it also requires a new framework for a human-robot interaction. And many groups address the problem in different ways. So they develop their own human-machine interface. For example, they use different physical devices to control the robots, such as a joystick, a haptic device, wearable devices. They use different ways to convey visually the information and give feedback, so as graphical interface, and they develop different control strategies. But there is a lack of knowledge about what is the optimal way to convey all this information, what is the optimal way to control this system, what is the optimal control strategies. We don't know. And so what I would like to do is actually give an answer to this question. And so develop a series of comparative tests with many users, so endoscopists, comparing different human-machine interfaces. As human-machine interface, I mean either both or all of these. Physical interface to control the endoscopic tip. So for example, using the PlayStation joystick or hand joystick or the phantom haptic. I mean, control strategies and also ways to convey feedbacks. And in order to do so, I would like to recreate all these interfaces inside a common simulator. And this simulator is, of course, based on SOFA, and it needs to be open because we need to connect all these devices. It needs to be modular and scalable because I need to turn on and turn off the different modules that I'm using. It needs to be realistic because the user needs to actually feel the environment as it would be the real colonoscopy procedure. How to do so? The idea is to have these are, let's say, all the modules, big modules that I need. So recreating the model of the organ of different colon for different tests. So, and I'm doing this by 3D reconstructing the model from CT scans of from abdominal CT scan of the patients, and then applying a mechanical model to have a realistic deformation. Then have a model of the endoscope. So actually, in my case, it will be just a tooltip or a capsule endoscope with attaching a camera and a light on top of it. Then having different input interfaces, different control strategies from manual to more autonomous tasks, and being able to extract different metrics, which actually we will be used to decide to evaluate the performance, and so decide what is the best solution, the best human-machine interface. And then also I need a module for augmented reality in order to convey information visually. Here I show you, the video of the demo. So.
Perfect.
Can you see it? Okay, cool. So this is a small demo. Here on the right, you can see the 3D model. This is a simplified one because it's nicer to visualize it. And on the left, actually, you can see the internal view from the camera placed on top of the capsule. The capsule, I'm now, in this video, I'm moving it with now with the keyboard. And then the visualization is given using the Unity plugin, which I'm really new. So I just passed from standard software to having visualization with Unity. Here you see a deformation. And I wanted to show you a bit more further the deformation here. Here you actually can see a bigger deformation when I'm going through the splenic flexure, which, as you see, I'm touching. The deformation is given by the collision, so touching the walls. And I showed it to a doctor who actually told me it's pretty realistic. And this is a hard point to go, so I'm touching the walls, not because I'm so bad at controlling the endoscope, but also the real endoscopists, they have problems in these corners. Anyway, the idea now, what are the next steps to do is actually to be able to connect different devices. Also, for example, the Apti device, which I did it in the standard stuff, and now I need to connect it also with the Unity plugin, extract all the metrics. And maybe I was also planning to add the peristalsis, which is a natural movement of our bowel. I'll go back to my presentation. No, sorry.
Yeah, you just need to get back to the perfect. There you are. I think, is Martina still here? No, I'm not sure. I think she's been dropped. Martina, no, I don't see her. So I won't answer the question already, but I'm sure Martina is going to join us. Here she is. Perfect. So, and it's going to be the conclusion time. So the timing is almost perfect. You can now conclude.
I'm so sorry.
Martina. No, it's okay. It's okay.
I just disconnected. Anyway, yeah. So this is actually the end, and there was a last slide about the conclusion. But so these are the next step. Actually, it's a preliminary work. So I accept I'm happy to reply to any question, but also to accept any comments, suggestion, actually, on how to go on. Thank you so much.
Thank you, Martina. Is there any question? So for Martina, I see already one for you, which is, Dara asking for which Unity plugin is that? Where did you get this Unity plugin from?
Okay, so it's the Unity plugin from Eric Bernard from 3D System, Infinity 3D System, right?
Correct. Yeah.
Infinity, yeah.
3D, yeah.
Okay, sorry, I really just started to use it.
And François is adding 2 questions to that. I'm just adding one question while François is typing. Is how do you define the boundary conditions of your, where it is attached, and how, is that with the knowledge of clinicians or?
Actually, there is a literature about that, and there are some other groups created some models by attaching some parts of the colon. Like what I actually did is fixing some parts of the colon and then creating some springs on the splenic, on the flexures, which actually handle the colon.
Okay.
These are the constraints that apply.
So yeah, do you constrain the full shape? So it was, yeah, sorry, Eric, I did not see your
not the full shape, just some parts.
Just location, yeah, some
location.
location.
Just those that are actually clean, usually they are fixed. No, sorry, not usually they are fixed. That in the real practice, they are more fixed with respect to others that they move more.
All right, thank you for answering mine and Eric's points. François, do not hesitate to also take the mic. Yeah, perfect. I think it is notoriously hard to acquire the geometry of a colon reliably on a scan. Did the one you show was reconstructed from a real data or more an artistic model? Are you an artist, Martina?
So actually, the model that I show, as I said, is a simplified one. So it is an artistic one. But
yeah, the 2 red
this
ones,
one here,
yeah.
So the one in the video is the artistic one, and you're right. But this one here, I reconstructed them from the 3D scan from CT colonographies. And here, for example, in this kind of 3D models, maybe I will need to open up a bit these parts that maybe are too small, too thin. So you maybe need to have some additional work on top of it, but the results are not bad actually.
So thank you for answering the points. So yeah, it looks good. Yeah. You had a second question, François. We just chatted a bit privately. We'll take a bit of time after this last session so that there will be some breakout rooms so that you can talk to Nazim, talk to Martina, and the last presentation will be the one of Paul talking about surgical robotics. So stay connected. There will be time for further questions. Okay, so François, you can keep yours and join Martina afterwards as well.
Thank you so much.